friends, good morning. Jordan's Lemma assignment 3. The exercise is evaluate integration from 0 to infinity sine square x over 1 plus x square whole square dx. Now in this kind of integration, I'm having the power in the sine function. I don't need any power over here because I need the functions only as sine or cosines without the powers, as sine of mx or cos of mx, right? I need to change in e the power iota m z. Now here I'm having the power in the sine function. I have to remove that power. For that I know that the sine square x is equal to 1 minus cos of 2x over 2, right? So just write down instead of sine square x as 1 minus cos 2x over 2 and rest of the integration as it is. And then we will integrate fz is equal to 1 by 2 integration 0 to infinity 1 minus, yes, here m is 2. So e the power iota mz will be changed to e the power 2 iota z, right? Over 1 plus z square whole square dz along the given contour. You all know that. Now finding the poles of fz, just take the denominator equal to 0 and then you will be getting z is equal to plus minus iota. Yes, it is double pole. So clearly fz has double poles of which z equal to, yes, plus iota lies inside the contour C. Now I am going to calculate the residue of this function at z equal to iota, right? Because I'm having the denominator, I'm having the power in the denominator, so I cannot use that short trick method. I have to apply the formula for the residue, and the formula is residue of fz at iota is equal to limit z tends to iota d by dz of z minus iota whole square into f of z. So this is equal to limit z tends to iota d by dz z minus iota whole square. Our function is, this is 1 minus e the power 2 iota z over 1 plus z square whole square, right? So I'm writing this f of z as 1 minus e the power 2 iota z over, this is 1 plus z square whole square. Alright, can I separate this as z minus iota whole square and z plus iota whole square? That z minus iota whole square, that will be cancelled out. So I'm lefting up with 1 minus e the power 2 iota z, and taking the denominator in the numerator, I will get 1 plus z square the power minus 2. Sorry, I have to write here iota. I'm very sorry, because this is now z plus iota. This 1 plus z square whole square is changed to z minus iota whole square and z plus iota whole square, right? So I'm lefting up with this only. So this is equal to taking the derivative of this function with respect to z. You have to take first function, then derivative of the second, plus second function, derivative of the first, right? So limit z tends to iota, first function e the power 2 iota z into derivative of the second one, this is minus 2 z plus iota the power minus 3 plus, now the second function into the derivative for the first function, this is minus 2 iota e the power 2 iota z. Simply put the value of z equal to iota over here. You will get 1 minus 3 e the power minus 2 over 4 iota. Okay. Now by Cauchy's residue theorem, I know that integration over that contour C f z dz is equal to 2 pi iota times the residue. And the calculated residue is 1 minus 3 e the power minus 2 over 4 iota. Now taking this contour along real axis and also along the tau, the semicircle in the upper half plane. So integration will become negative r to positive r f of x, writing f of x as, right, I'm writing here as f of x first dx, and this is f of z dz. As you all know that our given function is tending to 0 as z tends to infinity, and also that function is a meromorphic function in the upper half plane, as I have already discussed in the previous example. You can note down from there. So this is equal to this. So from that, this limit r tends to infinity integral over this tau fz dz is equal to 0 by Jordan's lemma. Because our function is a meromorphic function, and now because this is 0 by letting r tends to infinity, so I have to let r tends to infinity in whole equation 1. So this is minus infinity to plus infinity, writing the value for f of x as 1 minus cos of 2x over 1 plus x square whole square dx. Second integral is 0 by Jordan's lemma. So this is equal to pi by 2, 1 minus 3 e the power minus 2. Okay, fine. Now this is equal to, because this cosine, this whole function is an even function. So this integration will become twice 0 to infinity, 1 minus cos of 2x. Wait, I just need to change this because in the given integral I'm having sine function. So let me just get back to the formula. So this will change to minus infinity to plus infinity. This is 2 sine square x 1 plus x square whole square dx is equal to pi by 2, 1 minus 3 e the power minus 2. Again, this is your even function. This is 0 to infinity twice, right? So this is 2 sine square x over 1 plus x square whole square dx is equal to pi by 2, 1 minus 3 e the power minus 2. And then you will get, just take this 2 and do this is 4 to the other side in the denominator, and you will get 0 to infinity sine square x over 1 plus x square whole square dx is equal to pi by 8, 1 minus 3 e the power, sorry, it is 1 plus or a minus, it is, I guess, alright, it is minus, yes, e the power minus 2. Hence proved. Thank you so much for watching this video, and then next time again we are going to solve the more examples for the Jordan's lemma. Till then, take care, goodbye, have a nice day. Thank you.